Hello and welcome to my sofa. This is a quick demonstration of the new system and some points and things to mention about what it features and how it works. So as a quick demonstration, you just present your fob. It's audio and visual indication that something has happened, so it should be as accessible as it was before. And what happened then when I scanned my fob is obviously over the Wiegand, I'm going to call it one of them, interface over the white and green cables. The data is transferred into this Arduino Nano. The Nano just takes this interface and converts it to serial, which means that over USB it can go into my laptop, but what will eventually be a Raspberry Pi. There's Python code on there. All it does is it just takes in data from the USB, so reads it in, validates that the reader exists. I'll talk about that a bit later. Validates that the user is known, so there's a list of fob IDs in members.csv, checks that it exists, and if it does, it then fires the relay for 0.5 seconds. So some of the features it has is that it can tell if the reader exists or not. So if I go ahead and unplug this, I'll try not to short everything out, doing this one-handed. Very quickly the green LED will turn off and the error LED will flash, like so. Now what's happened there is, because of the Wiegand protocol, the two data lines are high when there is no data. When there is no reader, the lines obviously go low and it knows something's wrong. The Arduino then transmits that there is a problem through to the code, and you get a error. And so that way we know that something's gone wrong. And this means if someone unplugs it or something goes horribly wrong with the reader, it logs the error, and this can then be notified to the board, who can then take steps to fix it. Likewise, if we plug it back in, the green LED comes on because it knows now that everything's okay, and the board sends an OK message back to the code, which will then obviously can update. So we know that maybe it was temporarily unplugged, maybe something happened, but we know that the problem's now fixed. Another feature is the logging, which I'll go into now. We've got two types of logs that are auto-rotating. We've got our error logs, we've got our debug logs. Now our debug logs, I'm quite okay to show this because my fob ID is just a test one, but in this case it details pretty much everything that happens. So we can see here that there was data, it validates it and says that it was true, and then it details who scanned in. Not only scanned in, but also scanned out. So if I tapped on a second reader, it would then say scanned out. And what it means is that anyone looking at this can do a search for, scanned in, which will show all people scanned in. Fob ID they can search for. Likewise, this will bring up everything of that person. And you can just search for RFID fob scan. So for COVID tracking, this is super easy. It also features the error log. Now the error log is the one that is probably most important. So if there's a reader error, so in this case when I unplugged it, it detected that the reader wasn't connected to the Arduino. This is logged, which means that the board can take action. Now the thing about error logs is the Pi checks constantly for the error.log file, and if it exists and if it's got a size of more than 0 bytes, it will set an error LED on. And what that means is when you come and go into the space, people who are sort of maintainers, people who are the board members, people who are looking after the system can visually see that there's a problem and then can go to take steps to fix it. All the components are modular, so you can see we've got two Arduinos there. Everything fits together, it's all standardized. The connectors which are coming soon are going to be the DIN ones. I think I've ordered 8-pin DIN connectors. We've got two for the Wiegand interface. We've then got the other two. One is for the green LED on the reader, and one is for the beeper. Now, and I'm not going to show you this because it's got a couple other test IDs, including my actual space fob ID. If I go into members.csv and if I change my fob ID, so now this fob won't be recognised because I've removed it, I've edited it from the file. If I now present it, you can see it obviously hasn't worked, and then in the code it obviously doesn't let me in. In terms of tapping in and tapping out, tapping in will be the same as it always has, but tapping out may or may not, depending on the configuration, unlock the door. So it may be that when you're leaving, you just tap your fob, it lets you out regardless of whether it's acknowledged or not, given that it's optional and we're not trying to force people to tap out. It's just an encouragement. And we also need to let people out, of course, in case of fire, or if people just want to pop out, or if people just don't want to do it. It's totally fine. So the whole package is basically going to be in one box, apart from the reader. So we're going to have the Pi, we're going to have the Arduinos, and we're going to have the power supply. This just takes 12 volts, which comes from some generic adapter. But in reality, we'll take power from the UPS, which has been constructed in the space. That then converts 5 volts. As you can see, we've got a plug there. So in the end, this will plug into the Raspberry Pi, as you can see conveniently enough here. And then the two Arduinos will just plug straight into there. And so the whole thing will be powered from that. It's all very low current, so there should be no problems with that. We've got a relay board as well. This is very generic. We only really need one relay, but well, that's what I had, so that's what's going to do. We've got 4, so the others can presumably be used at some point. And this whole system is going to be in a box with a clear lid, so people who are interested can see how it works. It's easy to debug, it's easy to diagnose, and because these are mounted inside sockets, it's super easy to swap them out. So if somehow there's a lightning strike and everything blows up and catches fire, it's very easy to replace. Nothing is custom, nothing is impossible to replace. So that's a summary of the new system. It's still in progress, but once the new box arrives, things can be mounted, connectors can be made up, cables will be made up, and it should be simple to install. And the best part is that there's no modification to the existing system. When we want it to go live, we just unplug the reader. So in this case, imagine this is on the outside of the space. We just unplug it from the old system, plug it into the new system, and it should just work.